You fire up a massive Databricks cluster, kick off your job, and watch the bill climb. Or worse, your job fails mysteriously. Sound familiar? That's because clusters aren't just compute power, they are a strategic choice. Today, we are ripping apart every cluster type, from the basics to the advanced auto-scaling tricks that the pros use. Let's build your cluster confidence. Your cluster costs are exploding from this single, hidden mistake. It's the control plane. This hidden layer manages everything, scheduling jobs, monitoring workers, and storing state. If it's under-provisioned, your entire cluster grinds to a halt. Configure it correctly and you unlock stability. Get it wrong and you pay for idle workers while your jobs queue. This piece dictates your real performance. Do not think of the driver as just giving orders. It is the brain making millions of micro-decisions a second. It evaluates task dependencies, data locality, and resource availability to assign work intelligently. An inefficient brain means workers sit idle, waiting for instructions, or your cost skyrockets from poor scheduling. Master this orchestrator or watch your entire infrastructure bleed money. A cluster isn't hardware, it is a dynamic agreement on how to behave. When you provision a machine, you are just reserving a slice of a shared promise, a promise of compute, memory, and urgency. Break that promise with poor configuration, and the entire system fragments, turning coordinated effort into a traffic jam of orphaned processes and wasted resources. This single mistake burns more money than you might think. For job clusters, you are paying for processing power only when it is actively running your workload. Once your pipeline completes, the cluster automatically terminates and the charges stop. This is a fundamental architectural shift from persistent all-purpose clusters, turning compute from a constant expense into a true utility you pay only for execution, not idle uptime. Think of it like this: your all-purpose cluster is a leased corporate office with rent due every day. Your job cluster is a fully staffed pop-up event space. You book it, the team appears, the work happens, and the moment it is done, everything vanishes. You are only billed for the time of the actual event. That's the power of utility compute. Stop treating your Spark infrastructure like a fixed cost. That's a legacy mindset. The breakthrough isn't the technology, it is the financial model. You are paying for continuous availability you do not need, which actively kills your data project's ROI. Why are you leasing a full-time factory when you only need a machine to run one batch a day? Your render farm is wrong. Here are the real mistakes. So, what happens when you need to let multiple teams run jobs at the same time, but you still need rock-solid isolation? You cannot do that with a standard cluster, and forcing everyone to wait their turn kills productivity. This is the exact problem that Databricks engineered high concurrency mode to solve. It's not a tweak, it's a fundamentally different architecture. High concurrency mode transforms your single-user cluster into a true multi-user platform. It's engineered to provide full process isolation and table-level access control built right on Apache Spark. This is the secret behind its magic. It lets your data scientists and engineers run workloads simultaneously, safely and at scale, without stepping on each other's toes. But here's the real surprise: the single-node cluster is your secret weapon. For development, testing, or even lightweight production, forget the complexity. You are avoiding the overhead of a full cluster while your local machine's resources get a massive turbo boost. It's faster, simpler, and often significantly cheaper. Do not waste money on power you do not need. Your biggest bottleneck isn't content, it is your own database cluster. The default settings are almost never right for you. They are too slow, burning cache during lulls, and can crash under pressure when you need them most. You must tune the scaling rules, set aggressive scale-out triggers for performance, but conservative scaling delays to avoid wasteful, costly thrashing. Your configuration is your control panel. So, what are the right numbers for your cluster? It's not just a guess. Your max must be set to your true peak demand. But your min, that's your baseline cost. If you set it too high, you are bleeding money every single hour. Set it too low, and every new job starts from a cold, slow crawl. Imagine that spiky load hitting a static cluster sized for the average. You watch in horror as resources max out, jobs queue, and everything slows to a crawl. The dashboard bleeds red. Now, with auto-scaling, watch new nodes seamlessly spin up, handle the surge, and then scale back down. That's the power and the relief of true elasticity. Your editing bottleneck isn't your skill, it is your cluster setup. Picture your team provisioning dozens of clusters. Without these guardrails, costs skyrocket overnight. Cluster policies lock down allowed instance types, enforce essential auto-scaling, and automatically apply tags. This is your enforcement layer. You define the rules once, and every new cluster, whether created by a data scientist or a new engineer, complies, preventing budget disasters before they happen. The guardrails are now set. Imagine this, your new hire goes to create a cluster. The policy instantly steps in. They simply cannot select that premium GPU or massive 128-core instance. Their UI only shows the cost-effective, pre-approved options. You have just transformed a potential financial shock into a routine, compliant operation. Control isn't restrictive, it is liberating. Now think bigger. When you attach that policy to a group, magic happens. Every developer in that team inherits the rules instantly. You onboard a dozen new hires tomorrow, and they all get the right guardrails automatically. This is the power of scaling governance without the manual overhead. Your render farm is silently draining profits with every single frame. Imagine your compute budget as a fixed bucket of cash. On-demand instances are drilling holes in the bottom. Spot instances let you use what's spilling out, the spare compute in the cloud, for a fraction of the cost. For fault-tolerant work, it's not a gamble, it's collecting free money left on the table before it evaporates. Think about the hidden cost you never calculate: waiting. Your team is idle, staring at a spinning icon for 5 to 10 minutes while clusters build. Instance pools change the game. Think of them as a pre-warned, standing army of compute. Your cluster does not boot from scratch, it deploys instantly from this ready reserve, turning lost time into immediate productivity. But that army needs to be trained. An INIT script is your drill sergeant. It runs the moment a node boots, automatically installing your Python packages, Java versions, and security configs. You pre-configure the entire software stack, so every node in your pool is mission-ready the instant you need it, perfectly identical, flawlessly prepared. Your render farm is wrong, and it is silently draining your channel's profits. Forget performance alone. The real risk is over-provisioning, where idle nodes burn cache around the clock. You wouldn't leave lights on in an empty building. So, before you deploy, ask, is this workload predictable or bursty? Your answer dictates your entire cluster strategy and whether you are building a profit center or a financial leak. Open that cluster utilization graph right now. If it's a flat line, you are overpaying for idle capacity. If it's a chaotic spike chart, your auto-scaling is failing. This single metric tells you if your scaling strategy is working or if you are just throwing money at the problem. Master this, and you control both performance and your cloud bill. Do not make this beginner mistake. Your driver is the brain of the cluster. Starving it of memory means it crashes before the real work even begins. This creates a false bottleneck, killing all expensive executors at once. Right-size it first for your workload. It is the single most critical factor for stability and getting a true performance read. Choose the cluster type, all-purpose job, and mode based on your user count and workload goal. Always use auto-scaling with sensible limits. It is your primary lever for cost control. Govern with policies to prevent bill shock and standardize configurations across your team. Try applying one concept from this video to your next Databricks job. Maybe start with auto-scaling on a test cluster and see the difference it makes.